Hello there, and a very big welcome as you join us live at the launch pad here at the European Spaceport in French Guiana. We are launching Sentinel 2C. It's a satellite to monitor our planet for the European Space Agency and the European Commission, and it's up there inside what we call the fairing. About 15 kilometers or so from the pad is the Mission Control Center. Teams in here going through final preparations inside what we call the fishbowl, that protective glass there. I'm Katie Haswell, and I'm here in the mission control in the commentary box with Damien Valadez from Arianespace. Thanks for being with us, Damien.
Great to be here, Katie.
We are launching the light lift at Vega today, yeah?
Yeah, and Vega is the first generation in the Vega series. Today it's its last flight before passing the baton to the upgraded version Vega C.
Indeed, more on that to come, but first let's go over to the flight desk now and to the CEO of Arianespace, Stefan Israel. Hi Stefan, thanks very much indeed for taking the time to chat with us. How are the final operations going?
Everything is going very well. All the parameters are now green. You know that to make the launch tonight, we need the basis to be ready, and the basis is ready. We need the satellite to be ready, satellite Sentinel 2C, which is ready, and we need our launcher to be ready after the final preparation, and the launcher is ready.
Good to hear. And this is an important mission, isn't it, Stefan, for Arianespace?
Yes, for sure, because this is the fifth satellite we launched for the Copernicus constellation, the fifth Sentinel, after 4 successful launches. And you know that in Arianespace we are very motivated to use space for a better life on Earth. Second, this is a satellite we launched for ESA and for the European Commission, and our mission is also to give Europe with an autonomous access to space. And last but not least, this is our 22nd Vega, the last of the first Vega generation series.
Indeed, and we're getting close now to launch of the last Vega. What can we expect to happen?
Yes, so we are going to lift off at 10:50 p.m. Local time. We are going to lift off towards the north. We will have the separation of the 3 stages, and after 6 minutes, a little more, we will have the ignition of the AVUM upper stage. And after the second ignition of the AVUM upper stage, we will have the separation of the satellite Sentinel 2C at an altitude of 775 kilometers, and after a mission duration of 57 minutes.
Fantastic. Well, thank you very much indeed, Stefan, and best wishes now for the rest of the countdown.
Thank you.
So, Vega on her pad, standing tall, about 30 meters tall, actually. You can see just on the top left of the boards there in the screens here in the Mission Control Center, scheduled to lift off in 16.5 minutes time. The countdown there on the top right-hand side of your screen. Vega is going to be lifting off, as I said, in about 16 minutes, Damien. What happens after that?
So Vega is composed of 4 sections. We call them stages. Their names roughly match the mass of their propellant in tons. So when the P-80 engine ignites, Vega heads north, and we can see its flight path actually on the right-hand side there. So the first stage will provide thrust for about 2 minutes, and it will then be separated once empty. The second stage, or Zefiro 23, will take over for about 2 minutes and keep on increasing Vega speed. Then the third stage, called Zefiro 9, will burn for about 3 minutes. And at the very beginning of this phase, the fairing will be jettisoned, as we don't need it anymore to protect the satellite. Indeed, it has passed through the dense lower atmosphere. As you guessed, the Zefiro 9 is then separated as well. And up next is an important step. So we've got the third stage separation. And coming up is the first ignition of the upper stage, the AVUM, which is rather special because it uses liquid propellants. It will shut down in a bit more than 10 minutes later. We will then have done we will have half an hour of a ballistic phase, which will lead us over Australia, where the AVUM second ignition will be carried out for 1 minute. shortly after, Sentinel-2C will be separated on a Sun-synchronous orbit, which means that the satellite will always be in sync with the Sun, allowing for consistent landing conditions for the areas observed. And the last step of this VV24 mission is a third Avum boost to reduce altitude and avoid leaving debris orbiting Earth.
Very important. And Sentinel-2C is part of the world's most advanced Earth observation system. It's a program called Copernicus, under the leadership of the European Union, where the European Space Agency is a co-founder and manages its space component. Day in and day out, the Sentinel satellites monitor our planet, giving reliable and up-to-date information.
Yeah, they work in pairs. It's basically twins in space, monitoring land and coastal waters. Sentinel-2A and B are already in space. 2C is going to replace 2A to continue the service and replenish the constellation.
Indeed. So let's take a closer look now at Sentinel-2C.
Tonight, the Sentinel-2C satellite, a key element of Europe's Copernicus program, lifts off on the final Vega launcher. The satellite will enhance the capabilities of its predecessors, Sentinel-2A and Sentinel-2B, by providing crucial data for Copernicus services until at least the year 2030. Equipped with a range of cutting-edge instruments, Sentinel-2C delivers high-resolution images in 13 spectral bands, allowing scientists to accurately track changes in the Earth's surface, including in vegetation, soil and water cover, among others. Thanks to the Copernicus Sentinel-2 mission, we are also able to monitor floods, fires and volcano eruptions. The two-satellite constellation will systematically monitor the entire planet. Additionally, they will provide near real-time data for disaster response. Just like all Copernicus Sentinel satellites, 2C makes high-quality, up-to-date imagery freely available for a wide range of uses worldwide. This data empowers informed decision-making in environmental management and policy development. Designed and built by a collaborative effort involving over 60 companies led by Airbus Defence and Space, it is an outstanding example of Europe's excellence in developing advanced technology and managing a large project on a multinational basis. The Sentinel satellites are part of Copernicus, the Earth observation component of the EU space program, managed by the European Commission EC and in partnership with the European Space Agency ESA. By joining its predecessors, Sentinel-2C will contribute to delivering crucial insights for future generations.
So as we heard there, the Sentinel-2s are a great example of Europe's technological expertise as a space power, and built by a consortium of some 60 companies in Europe and the US, led by Airbus Defence and Space in Germany, with Airbus France responsible for the innovative high-resolution multispectral imager.
Yes, and it's the first Earth observation mission of its kind to include 3 bands in what we call the red edge. But what's the red edge? It's a special type of light beyond the visible red spectrum. It is used to detect subtle changes in plant health invisible to the naked eye. That means that the Sentinel-2s give us key evidence about the health of the world's vegetation. It is very important for global food insecurity, and they can also help in urban planning, decision-making during emergencies, or understanding our coastal water, which is very important as we face demand for water.
Yes, indeed. And of course, Sentinel-2C is travelling on board the light launcher Vega, as we said earlier. It was designed primarily to carry small satellites like Sentinel-2C, Earth observation and scientific payloads to different orbits close to Earth. And today is the last flight for the first generation base model, so it's kind of important, isn't it?
That's right. We launched the first Vega from the spaceport 12 years ago. So today is the 22nd launch, and next we hand over to the upgraded version Vega C. The Vega program is a great example of teamwork between 10 European countries.
Yes, and of course the prime is Avio, the prime contractor for Vega and Vega C, and Arianespace operates it. Vega has delivered some very important spacecraft over those 12 years, so I think this is a very good time for us to take a look back at the highlights of her career.
4, 3, 2, 1, top. Allumage contrôle.
L'avventura di Vega continua.
It does indeed. The adventure continues with Vega C, which is, of course, an upgraded version.
Yeah, Vega C can carry up to 2.3 tons of payloads as compared to Vega's 1.5 tons, thanks to the two upgraded solid propulsion stages. It also features an enhanced upper stage, a new fairing, and updated ground infrastructures. But for now, let's set some good vibes to the first Vega for its last flight, first gen Vega.
Yeah, indeed. Good vibes coming your way, first gen Vega. So right now, this kind of point before launch, 6.5 minutes, you can see the screens here in the Mission Control Center. On the left-hand side, everyone's looking at those boards. The green status panels, the fact that they're green is a good sign. They're showing us the go, no-go status of all the systems across the base.
Yeah, it's a bit like a pre-flight checklist for an aircraft. So the panels are showing the health of the three main systems, rocket and launch pad, ensemble de lancement et lanceur, the satellite, and what we call the range. So that includes telemetry, radars, the weather, and safety. And for now, I can tell you weather is green, so that's great. That's the last check, 10-minute check, weather.
Well,
green.
that's really good to hear. And the teams monitoring all of this are in the Launch Control Center, or CDL, as it's known here. We can see them here. What are they doing?
So they are protected inside a concrete blockhouse. This is where we get the rocket and its pad ready for liftoff. Right now, some of the teams are watching over these final important operations in the countdown. Others are doing actual operations and switching systems on and off. So you can see a door at the end of the room. This leads to another room where the technical authorities are. They are constantly monitoring the systems in real time. If anything seems off track, they communicate and troubleshoot. The frontline teams here at the Guiana Space Center are supported by another team of experts in Europe.
That's right. They are in Colleferro. They are in near Rome.
Yeah, they are the Avios technical support unit. They are also following the launch in real time. It means more brain on the job, and it's good for solving issues as fast as possible.
You can never have too many brains on the job.
Of course.
So, all very focused, of course, right now, 4 minutes and 37 seconds to launch. We're coming up to the beginning of the next phase, which is the synchronized sequence or the automatic sequence, the last 4 minutes of the countdown.
This is a crucial phase. The rocket will become progressively automated. During this time, computers manage an impressive list of operations, and the team in launch control are closely monitoring them all.
I couldn't hear there, but I think we have announced the beginning of the synchronized sequence. So we'll be hearing the voice of the range operations manager throughout the launch, of course. We have a fixed launch time today. We don't have a launch window. So teams have been working here at the Guiana Space Center for 2 months now to get the rocket and the satellite ready for today. We call this preparation process the launch campaign. Damien, what's been happening during that time?
So most part of Vega arrived in French Guiana on a cargo ship, and they were then transported by road to the Space Center. The PAT, the first stage, arrived on a mobile platform at the Vega launch pad and was hoisted into the mobile gantry. Next, the second stage, the Zefiro 23, was lifted and assembled on top the first stage. The third stage, the Zefiro 9, was then integrated on top the Zefiro 23. Finally, the Avum upper stage was unloaded and assembled on the Zefiro 9. Sentinel 2C arrived on a new ship called Canopy, which has sails. You can see the masts.
Amazing.
Yeah, it was transported to special clean rooms and prepared in controlled conditions with operations such as the fit check. So you can see there is a technician here actually checking that it fits.
I'm glad to see that it does.
Me too. Sentinel 2C was then integrated onto its adapter and moved to another building. There it was filled with propellant. The team wore special suits for safety reasons. And after assembly, the satellite was enclosed in the fairing. The upper composite was then transferred to the launch zone, as you can see here, and hoisted onto the top of the launcher and integrated with the upper stage, the Avum. There you have it. With the launcher ready, the mobile gantry was removed just hours before liftoff, and the last Vega is ready for its mission.
And there she is standing on the pad, getting ready now, 1.5 minutes to lift off. Right now, all the panels are green. As you mentioned, Damien, the weather's looking good. It's been very hot here in French Guiana. So let's listen to the range operations manager. Right, we are 1 minute to launch. We're live at the European Spaceport in French Guiana for the launch of Sentinel 2C. Our very best wishes to all the teams.
Go Sentinel 2C.
They're off. Sentinel 2C and Vega are blazing a trail across the equatorial skies here over Europe's spaceport in French Guiana, heading north out over the Atlantic towards the Caribbean islands, burning the first 3 stages. The first stage, of course, burning now, getting us away from the gravity of the Earth. Vega really shoots into the sky, Damien, doesn't she?
Yeah, it does, and we could feel the rumble tumble here in the commentary cabin. So the P-80 delivers a powerful thrust about 230 tons, equivalent to twice its weight. It just results in a very rapid acceleration. So the first stage, its mass in propellants is 89 tons, and it is made of a special material called filament wound carbon epoxy.
And we're looking here at fantastic images and separation there of the P-80 first stage and switch on of the second stage, the Z23. So at this point in time we've lost about 2/3 of our weight, and we're hearing that the propulsion is nominal. So, and the trajectory is nominal. And of course the idea is to get rid of mass when it's no longer needed.
As soon as each solid stage has used its propellant, yes, we jettison it. So that's why we split a rocket into different stages to avoid dragging unnecessary mass into space.
And we're burning the Z23 second stage, Z for Zafiro, which is a type of wind, a gentle and favorable west wind.
It is often associated with bringing speed and good weather. It very much aligns with the goal of the Vega launcher, which aims at providing reliable and efficient access to space. So, Katie, it's a poetic note to the idea of a smooth and successful journey.
And the fairing at the front of the rocket there, you can see Sentinel 2C inside. And we're getting news there that coming towards the end of the burning of the Z23. Our altitude there on the top right-hand side, 113 kilometers above the Earth, and bottom, the vitesse is our speed, traveling at nearly 4 kilometers per second. Separation there of the second stage, and there's a short delay before we then get the ignition of the third stage. That's to avoid any collisions up in space.
Absolutely. So,
and we have separation now of the fairing. That's been jettisoned. We don't need it anymore. And if you look at the altitude, we're 130 kilometers above Earth. We're hearing that the propulsion is nominal, and so is the trajectory. Everything going according to plan. And we can see Sentinel 2C, Damien, for the first time. It's that gold structure at the front.
yes, so we can see the 3.4 meter long satellite attached to the Avum upper stage. So the gold part is a thermal insulation. It was specifically designed in the 50s to protect satellites from the extreme temperatures in space. And since then, it has been developed for all kinds of uses here on Earth. That includes emergency blankets, like the one you might have in your car.
Well, I don't actually have one in my car, but I know the ones you mean. They're very crinkly and noisy. And you can see there we lifted off from the Guiana Space Center. The Galileo was the tracking station here, and now we're using Saint-Jean-du-Maroni. And if you look at the picture there, you can see there's just one solar panel today.
Yes, it is to maximize reliability and efficiency while meeting the satellite's power requirements. So satellites must be as lightweight as possible, as you know, and every kilo counts, every little helps. And so the speed should go just a bit under 8 kilometers per second, so we are heading toward that.
And everything is going according to plan. Everything is nominal. These images on the right-hand side are the computer-generated images. They're kind of a 3D animation of what's been planned right now in space, and they're pretty well as close as we can get to real-time imagery, aren't they?
Yes, so our mission analysis teams plan a precise set of events, and we put that in a computer, and it shows us the behavior that they have predicted, that includes orientation with respect to the Earth and the Sun. We put a lot of effort into it to make it true to life. The satellite is modeled from 3D plans, obviously. For the textures of the different parts of the satellite, we use photos to try and reproduce how they really look like. For instance, the thermal insulation that we just mentioned.
And it's really useful to have those images because, of course, the problem with space is that it's in space, so you actually can't see what's happening. Getting close now to separation, there we go, of the third stage. That's been confirmed. And so we've got away from Earth in 6.5 minutes. This is the speed, of course, that we're traveling, nearly 7.5 coming up to kilometers per second. So we can really start the next phase of the flight now, Damien. Our flight path takes us up north. We're heading up over the Caribbean towards the east coast of Canada. We're crossing the Arctic and back down over Southeast Asia to the west coast of Australia, and that's where we're going to be releasing our satellite. Why north?
So the satellite will be in a fixed position over the Earth, north to south, with the Earth rotating below it. Imagine, Katie, you're peeling an orange stripe by stripe.
I'm just going to stop you there. We've had confirmation of acquisition of signal at Bermuda. So yes, stripe by stripe.
Yes. The Sentinel-2s peel very wide stripes. Each swathe is nearly 300 kilometers, so they can image our entire planet in 5 days.
Amazing. And we've got the switch on time now. This is the scheduled moment to switch on the engine of the AVUM upper stage. We have that confirmed. This is an important moment, actually, in the flight. Trajectory is nominal, we're hearing. We've really started the next phase now of this part of the journey because the AVUM or AVUM has taken the wheel and its job is to deliver our passenger to its required orbit.
Yes, it must be very precise. We must release Sentinel to see on exactly the right injection orbit, nearly 800 kilometers altitude, with the correct inclination, which is 98.5 degrees. But first we have to get there, so the first AVUM boost is for reaching an intermediate elliptical orbit. After that stage, we'll cut off.
And AVUM means attitude and vernier upper module. Bit of a mouthful.
Absolutely. So in engineering, a vernier is a precision tool. It refers to the precision required of the AVUM, which can deliver satellites at different orbits. So it needs to perform satellite fine pointing before separating it. That is why we need liquid propulsion. It allows for more precision maneuvers than powder, because powder is more suited to provide raw power.
Indeed. One of the features of the AVUM upper stage is that it can actually restart its engine. And for Vega, the first generation model, this one that we're using today, that's up to 5 times. But for Vega C, it's even more, isn't it? And I know this is important, but just can you explain to people why?
It allows the AVUM to deploy different payloads into separate orbits, much like an elevator, stopping at multiple floors. It's a big advantage of the Vega series. Not all launchers can actually reignite their upper stage. So today there is only one separation for one customer, but for some launches it's common to adjust the orbit between 2 or more separations. So Vega C has the impressive ability to reignite its engine up to 8 times. This allows us to reach up to 3 different orbits with Vega C.
And that's very, very important when you've got different passengers wanting to get off the bus at different bus stops. So here we are 10 minutes into our flight. We are 310 kilometers high. We've traveled nearly 3,000 kilometers across the planet if you were to draw a straight line along the Earth. And our speed nearly... oh. You'll have to excuse me, folks. I've got a bit of a cough.
Yeah, so basically we will be now picking up the signal in Gatineau in Quebec, Canada in about just a few seconds. We are waiting for confirmation.
Indeed, and if we look at the left-hand side of our screen, we can see the planned flight path with the white cross is the actual position of the rocket.
So we just acquired Gatineau. Hello, Gatineau.
Hello, ladies and gentlemen, boys and girls in Gatineau in Canada.
So the speed is roughly 7.5 kilometers per second. That's the equivalent of 27,000 kilometers.
And we're looking here at the teams at the CVI.
Yes, absolutely. So they are based on the Montagne des Pères. It's on a hill just a few kilometers away from us. The Quick Look Telemetry, or CVE in French, team, they depict the current status and any significant findings from the telemetry data. These steps ensure that everyone involved understands the situation and potential issues. They pass on the info to the Range Operations Manager, the DDO, in the mission control room. And the Range Operations Manager is responsible for announcing the confirmation of major events such as stage separations, engine cutoff, and successful payload deployments.
So they're doing very, very important work there.
Absolutely, and everything is still nominal.
Now, you might have noticed the logo for the city of Sevilla in Spain on the fairing of the rocket, and that's because this year Seville has taken over the presidency of the Ariane 2024 Community of Cities in partnership with Airbus Defence and Space. It was set up in 1998 to strengthen cooperation between people involved in the space industry. Let's hear now from the mayor of Seville, José Luis Sanz.
En 2024, la ciudad de Sevilla suma la presidencia de la red de ciudades Ariane, formada por cerca de 20 ciudades y otras asociaciones empresariales europeas vinculadas a la industria aeroespacial. Sevilla se convierte en la capital espacial europea. Hoy somos un referente, siendo uno de los principales hubs del sector aeroespacial europeo, epicentro de la industria espacial en España. Y para su celebración, Sevilla está desarrollando un amplio y diverso programa de actividades técnicas, culturales y educativas. Este gran programa es fruto de la colaboración público-privada y con la estrecha cooperación de Airbus, nuestro partner en la presidencia, pilar fundamental de la industria espacial nacional. Además, está involucrado todo el sector aeroespacial sevillano, junto con otras entidades públicas y privadas, miembros del Foro del Espacio, que representa una importante industria con más de un siglo de existencia y consolidada, con compañías representativas como pueden ser Alter Technology, SolarMens o CATEC. Es todo un honor que bajo nuestra presidencia de Ciudades Ariane se celebre el vuelo inaugural del Ariane 6 en el Puerto Espacial Europeo de Kourou, en la Guiana francesa, símbolo del posicionamiento e influencia del sector espacial en Europa. Este proyecto servirá para atraer inversiones a Sevilla, para proyectar internacionalmente su tejido empresarial y para captar fondos de proyectos europeos. También nos ayudará a difundir entre los sevillanos los beneficios que reporta la actividad espacial para Sevilla y nos ayudará a posicionar a la ciudad como la gran ciudad tecnológica e innovadora del sur de Europa. Desde Sevilla, capital espacial europea, nuestros mejores deseos para Ariane 6, porque sus éxitos serán buenos para Sevilla, para España y para toda Europa. Muchas gracias.
So that was hearing there from the Mayor of Seville. It was great to hear from him. And just a quick word to let you know that we seem to be having a few difficulties actually hearing the Range Operations Manager today. But Damien and I are receiving the information directly from the CVI, who are getting the telemetry from the tracking station. So we're giving you our confirmations that way, and Damien is able to confirm things.
Absolutely.
Back to our satellite, it's an important one. Our world is changing, the climate is warming, the population is increasing, and cities are expanding, and some of the biggest challenges are meeting the growing demand for food and water, keeping people safe, and forming strategies to address climate change. And looking down from space is vital for planning a sustainable future, which is why Copernicus, along with Europe's satellite positioning system Galileo, are key components of the European Union's space programme. Damien, let's just talk a little bit now about some of the applications for the information from the Sentinel-2 satellites.
Yes, so we talked earlier about how important the Sentinel-2s are in giving new insights into the world's vegetation that's important for land use and food production, for instance. Say you are a farmer, you might use satellite data to decide how much water or fertilizer to use. It can also be very much useful in planning how to respond in an emergency, such as floods or volcanic eruptions. So, for example, you might remember the fires in Greece this summer. We can actually see them on the screen. The wildfire near Athens. So a massive one erupted on August 12th. And this Sentinel-2 image shows it. So you see it uses a natural color combined with shortwave infrared to highlight the active fire fronts in red and the burnt areas in dark brown. The fire, driven by strong winds, produced a smoke cloud extending over 300 kilometers towards Libya, covering parts of Athens.
Absolutely terrifying. The Sentinel-2s can also help manage water resources, as we mentioned earlier, and not just for drinking, but also for agriculture, energy and sanitation. And that's because they can measure the health and changes to water bodies, and that's whether they're lakes, inland, for example, or on the coast.
Mm-hmm. Yeah, you can see here some coral bleaching in Florida. So in July 2023, just a year ago, record high sea temperatures were recorded around Florida, and they soared more than 2 degrees Celsius above normal, causing widespread coral bleaching in the Florida Keys. So this Sentinel-2 image shows the affected area near Isla Morada. Thanks to data from Copernicus, scientists can monitor these rising temperatures and their impact on the oceans.
And we're hearing there that all the parameters are normal. Interestingly, the Sentinel-2 can also help in predicting malaria outbreaks, but it can also help us understand animal populations.
Yeah, you will never guess what's the last image. It's a penguin colony discovered in Antarctica. So the Sentinel-2 satellites, with a resolution of 10 meters per pixel, offers a detailed view of our planet, leading to discoveries like these new penguin colonies. So it's an image from November 2016, a colony near Cape Gates, Antarctica. And it was not detected, funnily enough, by the penguins themselves, but by the large brown dropping stains, also called guano, that they left on the ice. So it helped scientists track these populations.
Who'd have known that penguin poo would be so useful? Coming up to the next phase now, Damien.
Yeah. Absolutely. So you can see we just switched off the engine now.
That's coming up at 18:30. Here we go. That's what it looks like up there.
Yeah, and we've got confirmation.
We have confirmation, yeah, indeed. So why are we switching the engine off now?
So the AVOOM has placed Sentinel-2C on an elliptical orbit, the shape of an oval, if you will, and now the altitude of the launcher is naturally rising. So when reaching the top, the maximal altitude of the elliptical orbit, the AVOOM will reignite to circularize the orbit as at its final altitude.
Let's talk now about Space Team Europe. It's in a mission like this, it's always the result of years of teamwork across Europe, and relationships are made and friendships are made. Space Team Europe is an initiative led by the European Space Agency, and it aims to bring people working in the field of space under the same umbrella, with no barriers or boundaries between companies.
Dunque, essere responsabile di una campagna di lancio significa presiedere la pianificazione e la gestione operativa di tutte le attività di integrazione e di test del lanciatore, nonché tutte le attività di preparazione del lancio. Attività che toccano diverse discipline, diversi perimetri, come ad esempio quello meccanico, quello fluidico, quello elettrico, avionico, e quello che noi chiamiamo di parte alta, che è la parte superiore del lanciatore, quella che è in diretto contatto col satellite.
Oggi sono direttore di stabilimento di Avio Guiana a partire dal 1 agosto 2024. Avio Guiana è un'azienda che opera all'interno del CSG dal 2020 con la responsabilità di mantenere le infrastrutture del sito di lancio di Vega nella sua piena efficienza e di coordinare le integrazioni del lanciatore Vega e Vega C in sinergia con la casa madre.
Donc moi je fais du CVI, ce qui veut dire du contrôle visuel immédiat, ce qui signifie qu'en temps réel, pendant la mission du lanceur, on va suivre un certain nombre de paramètres de ce lanceur, les analyser et fournir une synthèse de ces analyses vers le centre de contrôle à Jupiter pour le directeur des opérations, mais aussi pour la direction d'Arianespace, la direction du CNES, la direction du Prime Avio, et leur fournir les informations qui vont leur permettre de se rendre compte si le lanceur se comporte normalement.
The work of the program manager consists in managing the programs, in this case, in my case, the Vega-related programs, both development and exploitation accompaniment, along their lifetime. The lifetime of a program starts with the definition of the program proposal, the submission to the Ministerial Council. It is a matter to manage day by day the activities, to accompany the activities to their successful conclusion, taking always in mind and respecting the programmatic objectives, which are cost, schedule, and performance and technical requirements.
Sono responsabile sicurezza ambiente e SOGGUARD. Mi occupo di prevenzione e di gestione in tempo reale dei rischi lavorativi. Il mio ruolo consiste nell'assicurare il rispetto della normativa, valutando i rischi connessi alle attività svolte e di assicurare la protezione dell'ambiente, delle installazioni, ma soprattutto dei lavoratori. In più mi interfaccio con le autorità francesi e del centro spaziale.
We're going to take a short break now during this coasting phase and cut our microphones for just over 20 minutes. So we're going to keep the telemetry on the screen for you and the 3D animation. And we'll be back in about 23 minutes' time, just before separation of Sentinel 2C.
Yeah, so if I were you, I would stay tuned because the most important part is coming up.
It is indeed, the separation and releasing of our satellite. So we'll be back just before 11:40 here in Kourou. That's 3:40 in the morning, Greenwich Mean Time, and about 4:40 Central European Time. See you then. Hello again, welcome back. It's good to have you with us for part 2 of our live broadcast coming to you from the European Spaceport, the edge of the Amazon rainforest in French Guiana. We're 50 minutes or so into the launch of Sentinel 2C. It's an Earth observation satellite for the European Space Agency and the EC. You saw it there, lifting off from the pad here at the Guiana Space Center. Very beautiful images of the Vega launcher. Right now, Sentinel 2C is hurtling through space, attached to what remains of the rocket on its way to the orbit above Earth, just under 800 kilometers, about 775, where we will be releasing it.
Yeah, so that's actually 7.4 kilometers per second, and that's our speed now. So we lifted off at 10:50 Kourou time. It's the last Vega. So at 7:36, we switched on the AVUM engine for a 10-minute burn. We had a ballistic phase for 36 minutes. It's still ongoing, and in a few minutes, the AVUM is scheduled to switch its engine back on in 4 minutes, and we'll separate Sentinel 2C shortly after.
And on the left-hand side up there on the top of the screen is the trajectory, the white cross, the planned trajectory, the white cross is the actual launcher, the position of the launcher, the altitude on the right. We're actually at nearly 800 kilometers, 792. We've traveled 18,000, nearly 19,000 kilometers across the Earth if you were to draw a straight line. And our speed at the moment, we're traveling at 7.42 kilometers per second. So a reminder, if you're just joining us, that Sentinel 2C is going to replace Sentinel 2A to continue the important work of Europe's Sentinel 2 satellites. They're looking down from space to help us better understand our planet, and they have some very clever technology on board, right, Damien?
Yes, so the telescope and mirrors are made...
He's just telling us that we have acquisition of signal at the new Norcia tracking station.
Yes, that's great news. So the telescope and mirrors are made from silicon carbide, a material first pioneered by Airbus. It ensures high stability and minimal distortion from temperature changes. It basically results in exceptionally clear images. So this quality is just unmatched in its category. So each Sentinel-2 satellite collects 1.5 terabytes of data per day after onboard compression. So that's a lot. Counting in 4K movies, assuming we are going for a super good quality of 30 gigabytes a movie, that means the equivalent in terms of storage of 50 ultra-high definition movies.
That's a lot of movies, yeah.
Indeed.
You need a big hard drive to store all of those. So we have traveled, we lifted off from the northeastern coast of South America, and we flew over Canada, over the Antarctic, back down over Southeast Asia, and we're now approaching Australia. In fact, you heard there that we picked up the signal at the tracking station in New Norcia. And the upper stage is orientating itself to get ready to switch the engine back on. Amazing to think that it's only taken us about 53 minutes to get to Australia.
Yeah, I mean, like, you could be flying there from Paris and it would take you 25 hours.
It would, indeed. So, New Norcia tracking station, that's just near Perth?
Yes, about 1 hour and 30 minutes drive north of Perth. So the teams play a crucial role there in New Norcia 2 in supporting fast-moving satellites and rockets during the launch and early orbit stages. So it supports a variety of missions, and that includes, of course, Ariane and Vega. It provides critical tracking services for deep space missions such as Bepi Colombo, or the more recently launched JUICE last year, the Jupiter Icy Moons Explorer, of course.
An exciting mission.
Yeah, definitely. So I remember when we were waiting for JUICE to send its signals through that antenna, we were doing an interview with New Norcia when they picked up JUICE's signal. We all got emotional there in Jupiter because it meant that JUICE's journey was really beginning.
Yeah, it must have been. I can just imagine.
Deuxième allumage de la VOM.
We have a switch on of the second boost for the AVUM upper stage. It switched its engine on again for the second time. All going according to plan, all nominal. Why are we switching the engine on now?
So right now we are currently on an elliptical orbit, the shape of an egg, if you will. After the first burn that lasted 10 minutes, the AVUM and Sentinel 2C were actually put on that elliptical orbit, and we've now reached the desired altitude, and we want to stay there. We need to turn into a circular orbit. Hence, we are doing a second burn for about just 2 minutes to circularize our orbit.
And tell us about Sentinel 2C separation orbit versus this final orbit, as it were.
Yeah, so it was initially placed 11 kilometers lower than Sentinel 2A and 2B at nearly 800 kilometers. At a lower altitude, it orbits Earth slightly faster. Over the 38 first days, it will gradually catch up to Sentinel 2A and B. So once in position, its altitude is raised to match the other two satellites, and this maneuver stops drifting, and it keeps the distance between all three satellites constant.
Next event coming up will be the cutting off of the AVUM upper stage. We have 20 seconds left of the burn on the AVUM upper stage. That's how it looks up there in space. You can see the curvature of the Earth and the thin blue line, of course, the atmosphere of our planet. That's all that protects us from space. Coming up now on AVUM cutoff.
Deuxième extinction de l'AVUM.
And we have confirmation there. Second switching off of the AVUM upper stage confirmed. We're on the targeted injection orbit required for Sentinel 2C. The separation actually is going to start pretty soon now, in a matter of seconds. And he's telling us that the orbit is completely nominal. We can see there, Damien.
Début de la manœuvre d'orientation au profit de Sentinel 2C.
Beginning of the orientation maneuver, getting Sentinel 2C ready to be released onto its orbit.
Yes, so the altitude is just where it needs to be. The speed is 7.6 kilometers per second, so it's the same speed as the ISS, roughly.
Séparation Sentinel 2C.
We have separation there of Sentinel 2C. That's good news. We are looking at happy faces in the Mission Control Center here, Jupiter Mission Control Center. That's excellent news. Here we are looking at the teams in the fishbowl, the operational teams.
Yeah, everyone happy in the flight cell and within the client parts as well.
Sentinel 2C on its way now, heading out on its own journey. We've delivered it to space, and now it's heading out to make its own life. And of course, the teams at the European Space Operations Centre and also at Airbus taking on their baby now and controlling the satellite as it goes through the early operations to commission it. Vega having done a good job there and lifted off, operated like clockwork.
Well, definitely so.
Yes, everything went according to plan. So we're going to hopefully hear now from the CEO of Arianespace, Stefan Israel. Stefan, great to have you back with us. Thanks very much indeed for coming back to chat with us a second time. Good news, we've released the satellite.
Yes, it's an excellent news. We have perfectly completed the mission tonight. The satellite Sentinel 2C has been separated on the targeted orbit. It is a full success tonight. This is the 5th Sentinel satellite we deliver successfully, and I can tell you we are very grateful to our customers, the European Commission, ESA, to our partner Airbus, satellite manufacturer, to our prime Avio for this great success.
And what's next, Stefan?
Indeed, in fact, Vega is going to deliver one more time for Copernicus. It will be Vega C, so the next generation of Vega. And now with ESA, with Avio, we are going to prepare the return to flight of Vega C. And the return to flight of Vega C will be once again for a Copernicus satellite. It will be Sentinel 1C by the end of the year, so keep posted.
Absolutely. Keep posted indeed. Stéphane, thank you very much indeed.
Thank you. Thank you.
Well, now, we've talked a lot about our satellite, Sentinel-2C. Let's turn our attention now to the people who use the information which the Sentinel-2s provide. The Copernicus program currently has more than 750,000 registered users. That's 750,000 people who use the information coming from the satellite, and they can be anyone from farmers and environmentalists to emergency services and journalists just like me, receiving press releases in our inbox about the state of the climate, for example. And that information is completely free. It's a fantastic service and anybody can use it. And I have to tell you, I'm very, very impressed. But it's one thing receiving the data from the satellites. It's another thing being able to understand it and use it. And that's the job of the Copernicus program. And I'm absolutely delighted to introduce you to Usue Donizar, or Donizar, I think I should be pronouncing it with a better Spanish accent, who's joining us now. Usue, you are from the Copernicus Land Monitoring Program. You lead the Copernicus Land, let me just get this right, Copernicus Land Monitoring Service, which provides information about the land. And of course, Sentinel-2C is all about the land and the water. Just tell us a little bit more about, well, first of all, wonderful launch, eh?
Yeah, that was a wonderful experience, I have to say.
Yes. Yeah, did you see it? Did you go outside and see it with your own eyes?
I'm still trying to digest it.
Usue, tell us a little bit about the kind of people who use... in a minute, you can tell us about what you use the information from the satellite for, but tell us about the people generally who use the information.
So we have different types of users of Sentinel-2 data. We first have this type of people who actually know how to do, how to produce information based on the satellite imagery, and that would be me, for instance, 20 years ago. And then we have those people, which is a wider public, that do not really know how to process the data and do not really know how to create information on them. And what we do on the Copernicus Land Monitoring Services, we create information based on those satellite imagery, information on the, in our case, on the land cover, and also on the changes that are appearing on land, and also on biophysical parameters.
And what do you use that information for?
Well, we create different types of products. Maybe the easiest to imagine for a layman would be a digital map, so to speak, but that's far too simple. So what we are doing is, based on the satellite imagery, we analyze it, we analyze the time series of the images. We analyze a lot of images, acquired one after the other, and what we infer from them is things like crop classification. We also make analysis of the tree cover density over a certain area, or we are monitoring inland water and the quality. Another one, which is I think one of the most intuitive, is to give you a kind of cartography of the land cover, so what can be visible on land.
And what does this information actually tell you? I mean, how important is it?
Well, it's really important in our case. So the land monitoring service, actually, it's co-led by two different entities. I am leading it at the European Environment Agency, and then the Joint Research Center is leading it at global level. So at the European Environment Agency, we are doing it only within Europe, and this is because one of our main goals is to serve different environmental policies. What we're trying to do, sometimes successfully, sometimes not so much, is to create information that can serve the policymakers to take decisions on how to protect better our environment.
Now, Sentinel-2C is replacing Sentinel-2A. For anybody who doesn't understand how satellites work in terms of providing continual information. Can you explain why that's important and why we need to have two satellites in this particular configuration, and why it's important to replenish the constellation?
I think one of the biggest added values of Copernicus program is that it's a commitment towards consistency and coherence over time. So because we have a purpose in our case, which is serving the European policies, but it could be other purposes as well. In the case that you were mentioning before, the emergency management service, that's also quite a big purpose to be able to support the different administrations that are dealing with emergencies. It is important to know and to tell our clients, our stakeholders, okay, this is here and it's going to last and we are going to continue it, and it's not just a proof of concept, so to speak. It is
Début de la manœuvre d'orientation avant le troisième boost à Voum.
We're hearing the range operations manager there, just confirming that the next orientation maneuver is beginning for the in order to for the AVM upper stage to perform its third boost, which of course will be part of its deorbiting program. So, just coming back to Sentinel-2C and the Sentinel-2s in general, I mean, what other projects or applications could benefit from Sentinel-2's data? Because I know obviously you guys are using it for your specific purposes, but there are quite a lot of other applications and even some surprise ones, aren't there?
Yes, I mean, in fact, we are only doing, so we are not doing all that could be done with the Sentinel-2 because it's maybe in some cases it's not our mandate. But I think that for the wider public, the possibilities are endless. I have to say, I've been in the business almost for 20 years now, and when the Sentinels were launched, when we started receiving the images, the whole paradigm of how we work with the Earth observation changed. So we came from just using a single image, maybe two at most, that were actually taken up to 80% of the cost of the project. And now we have this whole time series to take advantage of it. So we could think about potentially monitoring of environmental crimes is one of the things that lately is starting to be really on top of really high in the agenda. We are already monitoring the status of the vegetation across whole Europe. Our colleagues at the Joint Research Center are creating now, for the first time, a land cover map at 10 meters for the whole globe, with a very, very high repeat time, so a very high update frequency. And all these things are only possible because Sentinel-2 is there for us.
It sounds like this is a very, very important mission for you, which is not just important for you, it's important for all of us on Earth. I wanted to ask you a little bit more about disaster management, because we heard earlier from Damien was talking to us, showing us a few slides and some of the work that Sentinel-2s have been doing. How important is it for disaster management and making better decisions when dealing with emergencies?
Yeah, I mean, one of the biggest added values here is that we have an updated image every 5 days. So this gives a lot of very powerful information to the civil protections that are working in the field to see how is, for instance, a forest fire, how is it evolving. You can see it almost near real time in a way. You can see also a volcano, how does it evolve, and this is all information that is very, very important for the civil protections to make sure that everyone stays safe.
And I guess because you are using the information from the satellites, you must really have a big input, do you, into how the satellites are created and some of the work that they do? I mean, how much influence do you have?
Well, the European Environment Agency, we are indeed part of the stakeholders that helped ESA define the Sentinel-2. because we are monitoring land, and therefore our requirements are graciously taken into consideration, of course, yes.
Very graciously, that's good to hear. Let's talk a little bit about how we use the information. Now, I did mention earlier that I do get the press releases from the Copernicus satellites into my inbox on my emails, but I mean, obviously, there are lots of different people using it, but I think what's really astounding is that it's free to anybody to use. And I believe I'm right in saying that the quality of the data, which is produced by Copernicus, is so high and so relevant that it's really transformed the Earth observation industry. And I know that you can access it through something called the Copernicus Data Space Ecosystem, is that right?
Yes, Copernicus Space Data Ecosystem, indeed. It's going to be centralizing all the data produced by the Copernicus services.
And how do you use it? How do you access that?
Well, we are currently actually in the land monitoring service is currently migrating the data to the CDSE, which is and this I have to say has been also a change when the Sentinels went up. It's not only about how much information we have. We also have much bigger volumes of data as well, and that also entailed that we needed to change how we serve our users and how the users can access the data, and that is key for the correct uptake of our products.
I guess really, I think as Europeans, we probably need to be very, very proud, don't we, of the Copernicus system? It's quite extraordinary.
It is extraordinary, and I think we should all be, and we can and we should be very proud of what has been achieved through the Copernicus program. It is amazing that we were able to build this biggest Earth observation program in the world. I feel a very, very small part of the engine, I have to say, and seeing today Sentinel 2C go up, it was amazing because you see the future somehow.
Well, tell us more about the future.
Well, it's exciting moments right now because we are shaping how will the service evolve in the next years from 2028 onwards. And what we are receiving, we are at this moment having a lot of conversations with our stakeholders, asking our colleagues in different DGs how could we serve better their purposes. And it's really exciting. I know it's not only about the Sentinels, it's also about all the other missions that ESA is working on, or is through the Copernicus contribution to missions. And it's really an exciting moment for all of us, I would say.
Indeed, and watching the Vega launcher lift off, I'm sure you felt the vibrations.
Wow, that was amazing. I have to say, I was not expecting to get so emotional. Let's put it that way.
We had a former colleague who used to call it the rumble in the jungle as the rocket flies over, because you really can actually feel the vibrations of the rocket in your chest.
Indeed.
Uzwe, thank you so very much for joining us and sharing your thoughts. It's been really fascinating to hear.
Thank you very much for giving me the opportunity.
Thank you. Uzwe Donithar, thank you very much indeed.
Hi.
So we are now 1 minute coming up to, 1 hour and 13 minutes, coming up to 1 hour and 14 minutes into our flight, and I am seeing clapping. That's a good sign. That means that we have acquired the signal from the satellite. So,
acquisition de la télémesure satellite par la station de Troll en Norvège.
And we have confirmation that the satellite Sentinel 2C has called home via the Troll tracking station, who's picked up the signal from the satellite and communicated it to us here. So that's fantastic news. Sentinel 2C is delivered and has sent its first signal home. So we are now hoping to hear from some of the representatives of the major organizations involved in today's launch. Damien's back with me. Damien, this is great news. We've got the signal.
Absolutely, I'm just thrilled. I was very excited when I saw the signal coming up from Troll.
And here we can see some very happy faces. And the Sentinel satellites are a collaboration between the European Space Agency, the European Commission, and industry. As we heard earlier, the industrial side involves people from 60 different companies, and I think across something like 13 countries. So it really is a massive, big effort of teamwork. We're going to hear from the representatives of those three entities who have been watching the launch here from the Mission Control Center. And here we are in our commentary box. Damien's back with me, I'm pleased to say. And yep, we're just okay. I think everybody's ready, so we can now talk to them. So I'd like to introduce you, and I'm absolutely delighted to introduce you to Christopher Katz, who's the Director of Satellite Navigation and Earth Observation at the European Commission, Rutger Hartwig, who's the Head of Institutional Satellite Programs at Airbus Defence and Space, and Giulio Renzo, CEO of Avio. But first of all, let's go to Simonetta Cayley, who's the Director of Earth Observation at the European Space Agency. Simonetta, you must be absolutely delighted. Congratulations.
Yes, we're absolutely delighted, thrilled about this successful launch of Sentinel-2C. Copernicus program is just another milestone in the super history of this program under the leadership of the European Union. And after 10 years, the first launch of the first Sentinel. We look forward this continuity of the data. It's going to be great for users after the commissioning phase, of course, first 3 months. We will provide data to users in the domain of land, disaster, marine, and much more. Also methane monitoring, crop monitoring, agriculture, and you name it. So we really look forward these new element of the Copernicus family. It's another add-on to the super history of providing an infrastructure, space one, to support the challenges of climate, environment, and sustainability. At this stage, I would only like to thank our main partner, which is the European Commission. It's a program under their leadership. We have many more satellites to launch in the coming years. We have already up and running 8 of those. And of course, I'd like to also thank a special thank you to the member states of ESA. We have quite a few here today with us in Kourou. Last but not least, of course, to Arianespace and Avio. They managed to take the satellite into the right orbit, and to industry. This is, in fact, a collaboration where industry plays a key role, and Airbus Defence and Space has built the satellite with 60 companies in Europe. So a great collaboration at Europe at work. And last but not least, I really would like to pay a tribute to the team, the fantastic team of the Earth Observation Sentinel-2 project, for their motivation, their professionalism, and really looking forward to the next step of this great program.
Simonetta, thank you so much. And indeed, Christophe, it really, Simonetta is absolutely right. It's been a fantastic product of teamwork, hasn't it?
Yes, indeed. I would like to thank all the partners who made this launch, a very successful launch today. ESA, of course, our major partner here in this Copernicus program, Arianespace, Avio, CNES, and of course the satellite manufacturer Airbus. I would like to thank them. And I think it shows when Europe works together, we can do really great things. And I think tonight is really a proof of that. A flawless launch. Everything worked perfectly well. So I'm really very, very happy. And it's also, as we are in times of Olympics, like a relay race between the last Vega and the next Vega C. You heard about it. It will be end of the year. And it's also a relay between Sentinel-2C and Sentinel-1C, which we will launch on the Vega C. So it's really, in Olympic terms, it's a wonderful night today.
Handing on the baton. Rüdiger, what's coming up next?
So please allow me first also to say a big thank you to the entire Sentinel-2 team, which is composed of our colleagues from ESA as well as from industry under the lead of Airbus. And also congratulations and thank you to Arianespace and Avio for delivering safely the satellite into orbit. The next step now will be the early operations phase under the lead of ESOC, the European Space Operations Center in Darmstadt, followed by the commissioning. And all this lasts approximately until early December, and then we go into the nominal operations phase.
And that's very exciting. And over now to Giulio. Giulio, that we've seen that was the last of the first generation Vegas. Now we're looking forward to Vega C.
Well, yes, you're right. This is an emotional night for us. First of all, let me thank the European Commission for the trust in our launcher. And as Christophe was saying before, Vega has been a key rocket for the Copernicus program, will continue to be, and Copernicus is a key program for Vega. So we really work together. I wish to thank them for their trust in our teams. But let me take this occasion at the end of the Vega program to thank our European partners, because this program has lasted 12 years, more than 100 satellites orbited to space. This would have never been possible without the great support of the European Space Agency that has promoted this program from the beginning. But I also like to thank Arianespace, because Arianespace has placed this rocket everywhere in the world. We have launched satellites from more than 15 countries around the world thanks to their global reach. I also wish to thank CNES. From CNES we have learned a lot. We have learned how to respect the rules of safety and many other things over the years, and I really wish to thank them. I also like to wish our Italian space agents who have supported the program from the beginning, and the Italian government who has been behind it together with the other 13 member states that have participated to this program. But let me also thank my team in Avio, who has done a tremendous job over 12 years, many successes, but also challenging times. And I could not have a better team, trust me, because they have been able to overcome challenges and turn to success again. And this is the greatest trust you can have in your team. And I'm really glad for that. And this is the reason why, as a last note, I would like to dedicate this flight to a close part of the team, a team member who unfortunately passed away a couple of weeks ago out of a very, very aggressive cancer. Mikhail Rudnik, he was the master of liquid propulsion in our team. Unfortunately, he's no longer with us, but he would wish to witness this success, so I want to dedicate this success to him. Thank you.
Thank you very much indeed. And congratulations to everybody for a very successful launch. Thank you so much. So it's mission accomplished for the last Vega launcher. Over now to Vega C, of course, as we've been saying. Sentinel-2 has joined its twin in space, and it's ready to do some very, very important work. But congratulations to everybody, Damien.
Yes, congratulations to the European industry for this major achievement, and to our friends at the manufacturers, and of course to all the ESA teams and to Europe. And well done to everyone at Arianespace and the Spaceport for an excellent job done.
Best of luck to everybody now with the next phase of your operations. Thanks for joining us here live at the Guiana Space Center. From me, Katie Haswell.
And me, Damien Valade.
Goodbye.
Bye.